So question number 1, a slab of thermal insulator has cross-sectional area 200 cm square and the thickness is 5 cm. Its thermal conductivity is 0.2. If the temperature difference between opposite surface is 75 Celsius, what is the total heat flow through the slab in 1 hour? So diberi adalah A, area dia adalah 200 cm square. Jadi kita convert kepada meter square jadi 0.02. Dan the meter adalah 5 cm, kita convert kepada 0.05 meter tak ada square. Thermal conductivity adalah 0.2 dan time nya 1 hour, kita convert kepada second adalah 3600 second dan temperature adalah 75 Celsius. So kita masukkan formula dia adalah Q over T equals to KA adalah 80 over D. So kita masukkan formula 0.2 darab 0.02 darab 75 over 0.05, kita dapat 6J over S. So kita darab 6 tu darab dengan time 6 darab 3600, kita dapat 21600. So akhir jawapan adalah 2.16 darab 10.04 Joule. Habis.
Number 3. Two metallic rods M and N with similar length and cross-sectional area are joined together and insulated. At steady state, the temperatures at their ends are shown in figure 13.1. The thermal conductivity of M is twice that of N. Calculate the temperature at their adjoint end.
Question number 3 ni, kita dapat tahu Sn sama dengan Sn, Am sama dengan An, Kn sama dengan 2Kn dan Kn sama dengan Kn. So, dQ per 2Tm sama dengan dQ per 2Tn. So, so kita masukkan formula tolak 2KNA, T tolak 80 per S sama dengan tolak KNA 20 tolak T per X. So, kita potong-potongkan semua ni, potong yang sama. So, 2T tolak 160 sama dengan 20 tolak T. So, kita pindahkan 2T tambah T dengan 160 tambah 20. So, dapat 3T sama dengan 180. Lepas tu kita pindahkan 3 ni ke bahagian kanan jadi bahagi. So 180 bagi 3, so dapat T sama dengan 60 darjah Celsius.
The surface of a space shuttle is hot due to air resistance during the re-entry into the Earth's atmosphere. The temperature of the shuttle during this re-entry is 215 degrees Celsius. Calculate the fractional change in its length if the take-off temperature of the shuttle is 23 degrees Celsius and its coefficient of linear expansion is 24 times 10 to the power of negative 6k negative 1.
Okay, so delta L sama dengan 215 tolak 23 dapat 192 Celsius. Untuk alpha pula sama dengan 24 darab 10 kuasa negatif 6. So, delta L sama dengan alpha L0 delta T. Kita pindahkan L0 tu bagi sebelah bawah, bahagikan dengan delta T. Akan sama dengan delta T per L0 sama dengan alpha delta T. Lepas tu kita sub nilai dia dekat alpha delta T. Kita akan, bila kita calculate, kita akan dapat 4.61 darab 10 kuasa negatif.
Question number 5. How much heat flows through a sheet of copper 1.2 meter times 0.8 meter of thickness 3.0 millimeter for 1 hour if the temperature of the surface are 30 degrees Celsius and 28 degrees Celsius respectively? From the question, we get to know that A is equals to 1.2 meter times 0.8 meter, which is equals to 0.96 meter square. And then X is equals to 3.0 mm. And if we convert it into meter, it is equals to 3.0 times 10 power of negative 3 meter. Next, dt is equals to 1 hour, which is 60 minutes, and we times it by 60, which is equals to 3600 seconds. T1 is equals to 30 degrees Celsius and T2 is equals to 28 degrees Celsius. Lastly, the thermal conductivity of copper is equals to 401.
For this question, we need to use formula dq over dt equals to negative ka dt over x. Substitute isolated the value. We can cut the negative symbol. The dt is 3600, and this is the final answer.
Assalamualaikum and a very good morning everyone. Today we'll be discussing chapter 12, additional question 6. So the coefficient of linear expansion of aluminium is 2.6 times 10 power of negative 5 K negative 1. Question A, what is meant by this value? 2.6 times 10 power of negative 5 increasing in fractional of aluminium length per 1 Kelvin rise in temperature. Question B, an aluminium cube with side 0.2 meter is heated from 20 degrees Celsius to 80 degrees Celsius. Calculate the increase in volume of the cube.
Equals to 2.6 times 10 power of negative 5 K negative 1. V naught equals to 0.2 power of 3 equals to 0.008 meter. Delta T equals to 80 minus 20 equals to 60 degrees Celsius. We know that the gamma equals to 3 alpha. So now we need to find the increase in volume of the cube, or we call it as delta V. So the formula is delta V equals to gamma V naught delta T, and then we sub the gamma, which is 3 alpha, and then we sub the value and we will get the answer, which is 3.74 times 10 power of negative 5 meter cube.
Define the coefficient of linear expansion, a fractional increase in length of a solid per unit rise in temperature. B, a 1.5 steel rod is attached to a fixed wall as shown in figure 13.2. At 30 degrees Celsius, a gap between the rod and the opposite wall is 5 mm. We are neglecting the expansion of the wall. At what temperature will the gap close? The coefficient of linear expansion for the steel is 12 times 10 negative 6 Celsius negative 1. So the original length of the rod is 1.5 and the temperature is 30 degrees Celsius. So we must find the total length, which is 1.5 plus 0.05 meter. So we get 0.05 meter from 5 mm, we change to meter. That's how we get the total is 1.505 meter. So we find the average length, which is the total length minus with the original length of the rod. So 1.505 minus with 1.5, we get 0.005 meter. So from that we get using the formula alpha original length and total temperature. Sub. That's how we get the temperature equals to 307.78.
Physics chapter 12, additional exercises, question number 8. A copper rod and aluminum rod of equal diameter are joined end to end and insulated. At steady state, the temperature of the free end of the copper is 100 degrees Celsius and the far end of the aluminum is 0 degrees Celsius. If the copper rod is 0.15 meters long, what must be the length of aluminum rod so that the temperature at the junction is 50 degrees Celsius? Okay, so the first step to tackle this question is to retrieve the important information from this statement. A copper rod and aluminum rod of equal diameter. Equal diameter means they both rods have the same diameter, hence they have the same cross-sectional area, which is given by the symbol A. Joined end to end and insulated. Okay, this system is insulated, means there is no heat loss to the surroundings. All the heat is maintained in both copper rods. At steady state means the rate of heat flow from one end of this rod to the other end of this rod is constant. There's a constant rate of heat flow. That's the meaning of at steady state. Temperature of free end of copper is 100 degrees Celsius. Okay, so we can first draw two copper rods, one copper labeled by smaller lowercase c, and then one aluminum labeled by lowercase a. So one end of the copper rod, the free end stated here, free end of copper is 100 degrees Celsius, so we label that. And the far end of aluminum is 0 degrees Celsius, so this is the far end of aluminum, 0 degrees Celsius. If the copper rod is 0.15 meters long, So we can just label 0.5 meters long for the length of the copper rod. We must find the length of aluminum rod, so the temperature at junction is 50 degrees Celsius. So first label the temperature at junction as 50 degrees Celsius. Okay, we already have the thermal conductivity of both copper and aluminum. Okay, since the question states here at steady state, we know it has constant rate of heat flow throughout both ends of the rod, from one end to the other, throughout both rods. So the formula for rate of heat flow is this formula right here, dq over dt. dq over dt is rate of heat flow, K is thermal conductivity, A is cross-sectional area, and dt over x is temperature gradient, or the change of temperature over the length of the rod. Okay, why is there a negative? Because a negative sign simply means the heat is always in the direction of decreasing temperature. Means this side is hotter, this side is colder, so the heat will transfer from one end, which is hot, to the end that is cold. Okay, heat always in direction of decreasing temperature. We can see here this is 100 degrees Celsius, 50 degrees Celsius, heat decreases, hence heat moves in this area, decreasing temperature. So negative K. Okay, since we know it is at steady state, means dq over dt for both rods is the same. The rate of heat flow for both rods is the same. Okay, since we already have all the information that we need to use the formula of dq over dt, we can simply just key in the information into the formula to get the length of the aluminum rod. Okay, so first we key in the information for the copper rod, because we have all the information for the copper rod. Negative K A dt over x, negative K, so negative 397. A, we just label A because A is a constant, we can just cancel out after. 50 minus 100, so 50 is this end, minus 100 because temperature gradient. We can use the formula y2 minus y1 over x2 minus x1. In this case, this is y2, this is y1. 50 minus 100 over the length of the rod, which is 0.15, equals to negative K A dt over x. Same thing goes here, negative K, K for aluminum is here, key in there. A, because it's constant, because you cancel out after. 0 minus 50, so 0 minus 50, 0 is this end, 50 this end, minus temperature gradient, over x. We can equate x to length of aluminum rod. So we can just cancel out the A because A is on both sides, divide both sides with A, and then we will get this 19850 over 015 once you multiply this, and then once you multiply this, okay, we will get 11,900. So by simply multiplying and dividing, we will get x equals to 0.09 meters. That's the length of aluminum rod.